Hey, what's up guys? Mr. Bella back here with a new lesson on mean, median, mode, and range, otherwise known as measures of central tendency. We're gonna get to some vocabulary first. So first of all, most of you guys have heard of average. If you don't already know what mean is, average and mean are used interchangeably. I'll put an official definition over here for what mean or average is and how to find it. We'll do some examples on that. So mean is the same as average. So you add up all the numbers in your set and divide it by how many numbers there are. Median is the middle number. So you take all the numbers, you have to put it in order from least to greatest, and you take the middle number. If there are two middle numbers in the median, then you take the average of those two numbers. So you add those two up and divide by 2. Mode is somewhat the easiest. You look at all the numbers and it's the number that occurs most often. If none of them occur most often, then no mode. But if, like, let's say the set was 1, 2, 2, 3, 4, 4, 5, 2 and 4 would be the mode. There would be 2 modes. And then range, a lot of times say, oh, there's a big range in scores or a small range in scores. Range is the highest number in a set minus the lowest number in the set. So if we had a test or something and the highest score was 100 and the lowest score was a 30, that's a large range. If, however, the highest score was an 80 and the lowest score was a 70, that's a very small range. All right, so now that we have the vocabulary taken care of, let's start off with some examples. Okay, so we already talked about range, highest number minus the smallest number. Measures of central tendency are mean, median, and mode. And let's start off with a very simple set of numbers here, 10, 20, 20, 30, and 40, right? So the range is going to be the highest value minus the lowest value. So the range is going to be 40 minus 10. So make sure it's a lot easier if you put it in order from least to greatest, because you know exactly what the highest number is and the lowest number. So the range is going to be 30. Now for mean, it's the same as average. You add up all the numbers, and then you divide by how many numbers there are. So in this case, I'm going to take the sum of the numbers, divide by the number of numbers. So 10 plus 20 plus 20 plus 30 plus 40, and you divide that by 1, 2, 3, 4, 5. There are 5 numbers there. Okay, so that ends up being 120 divided by 5. So that means the mean, if you divide those two, is going to be 24. So the average of those numbers is going to be 24. Median is the middle number. So thankfully it's already in order from least to greatest. But if it wasn't, the first step would be to order your numbers from least to greatest. It has to be the first step. The middle number right there, if you can see, it's 20. And then the mode is the number that occurs most often. So if you can see there, 20 shows up twice. So the mode is going to be 20. So before we move on, sometimes, like, well, why do we need those other ones? Average seems like the best. So there are certain times where median would be better than average. Most of the time when you're talking about home prices, you're talking about median home price. You almost never see mean home prices, like how much do homes cost in the area. The main reason for that is to not account for outliers. So outliers, there's an official definition for what exactly an outlier is that you can solve mathematically. But for the purposes of what we're doing, outlier is a number way outside of the data range. So like in this data range, if it was 10, 20, 20, 30, 40, and like 85, 85 would be an outlier. A lot of times the median takes care of any outliers. Okay, so like, for example, if you had a class of 30 students are all 10 years old, right? But you had one teacher there who's 35 or 36 or whatever. If you took the average of those students, the average would be like 11 or almost 12. That doesn't make sense. Like, oh, what's the average of the class? Oh, like 11 or 12. It's like, oh, so they're automatically going to think that if you walk into that room, there's going to be 11 and 12-year-olds there, but then they end up with 10-year-olds. So if you find the median, though, the median is just 10. So it ignores any outliers. Anyway, and then mode is also good, especially if your data contains non-numerical points. So like, what's your favorite color? Blue, green, green, blue, 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 red, purple, blue. So the mode in that case would be blue. So let's take a look at this. You're trying to find mean, median, mode, range of this set of data. If you're just finding the mean, you don't have to put in order, but it's good practice to do that just because median, mode, and range all kind of require it. So mean, I could just add those up. 420 divided by 6 numbers. Right, so my mean would be 70. If you look at the data, if you look at this, 70 seems about right. There's a 96, there's a 12, 74, 82. Right, so like a good indication of like if you divided by a wrong number or something would be like if it said my mean was like 100. That's impossible. Your average can't be beyond 96 or 12. So the average cannot be past that. Now the median. So put it in order from least to greatest, which it already is, but in this case there's 2 middle numbers, right? So if there are 2 middle numbers, you find the average of those 2 middle numbers. So you add up 74 plus 82 and you divide it by 2. And so your median is going to be 78. Finally, mode, you're looking at that. 74 and 82 show up twice, so you have 2 modes. And then finally the range, you take the highest number, which is 96, subtract the lowest number, which is 12, and you end up with 84. Okay, so here's an example with a dot plot. Shows recorded high temperatures for 6 days in Little Rock, Arkansas. Find the mean temperature. So we're at 6 days, mean. If you forgot how to read a dot plot, every dot that you see, that means this temperature showed up once. So this would be 45, and if you're adding it, plus 45. Okay, you add all those up, and you divide it by how many there are, which is 6. So if you do that, so if you add them up, you get 288 divided by 6, and you end up with 48. So the mean is going to be 48, which makes sense. Again, look at the temperatures. 48 seems like a reasonable mean temperature. Okay, so remember, if I added incorrectly or if I divided by 5, I would get a number way off of that. All right, so let's take a look at a word problem here. Number of minutes Marianne's been talking on her cell phone each month for the past 5 months were 494, 502, 46, 690, and 478. Suppose the mean for 6 months was 532. How many minutes did she talk on her cell phone during the 6th month? So there are several ways to do this algebraically, which I can show you later on. But one way to do it is create a bar model. So let's take a look at a bar model. It says the mean for 6 months was 532. That means that if you took whatever the mean was, 532, if you divided that by 6, if you divided some number by 6, it would equal 532. Well, you do work the opposite way. 532 times 6 is 3,192. That doesn't mean that they're talking for 532 minutes each month, but if the average was 532, that means if you took a number divided by 6, you get 532. So 3,192. Okay, so this is just like solving one-step equations, right? You multiply both sides by 6, and you get 3,192. Okay, so now how do we use that with a bar model? So this bar model represents all of the 6 months, right? This represents 6 months. So you have 594, 502, etc. You add something, and then here, this is your x. I don't know. But all of these have to add up to 3,192. So what do you think you should do? Well, that's right. You would add all of these up and subtract from 3,192. All right, so if I add all of this up, well, first of all, I have 3,192. And if I subtract this part of the bar, that is 2,650. So if I subtract those two numbers, I get 542. Right? So she talked on her cell phone for 542 minutes on the 6th month. And you can easily check this by adding all of these numbers up here I divide by 6 and seeing if it equals 532, which it will. All right, so here's the problem from Alex. The numbers of students in 9 schools in the district are given below. Note that these are already ordered from least to greatest. Good for them. So we have these numbers here. Suppose that the number 196 from this list changes to 205. Answer the following. What happens to the median? So before you go and recalculate everything, let's see if we can do something. 196 to 205. So for this becomes 205. It doesn't change the order because 205 is still the lowest number. What do you think happens to the median? Well, the median is the middle number, right? So did anything happen to the middle number? It did not. So it stays the same. Okay, so notice how like I could have gone about that way differently. I could have calculated the median and then wrote it there and then calculate the median again somehow. Not that much work, but still, it's good to know like how it affects it so you're not doing extra work that you don't need to. What happens to the mean though? Okay, so this becomes 205, right? Definitely does not stay the same, and it definitely does not decrease. You're adding, the 205 is bigger than 196, so it's bigger. So instead, it's going to be increases by, but we don't know what. So in order to do that, you can find the mean first with 196, and then find the mean with 205. All right, so with 196, it's 2,673 divided by 9, because there are 9 schools, and I get 297. I could add all of this up, which I will. I'll show you both ways. I could add all of this up, but actually, if I add it up, 205 is conveniently 9 more than 196. So that becomes 2,682. And if I divide that by 9, if you know anything about division, this should go up to 298. So that goes up to 298, right? So you didn't have to do a whole bunch of extra work and adding all of them up. You just had to know, okay, this number right here went up by 9. So you just add 9 to this number. And if you really wanted a shortcut, if I divided this by 9 and I got 297, if I divide this, if I added another 9 here, this number would go up by 1. So a lot of ways to do this, a lot of ways to take a shortcut. So in this case, it increases by 298. Whoops. See, I was not careful. The new mean is 298, but it actually increases by 1, not 298. So that's a kind of a tricky one. Okay, so hopefully that was helpful on finding the mean, median, mode, and range of a data set, and I'll see you guys next time.